Okay, so here we have the calculating the overlap issue. So I made a little field here. It's what, 3.4 acres, and it's a typical field, headlands. And here's a slough we had to drive around. This is a two-section section control, and the proverbial last pass, which is a little bit wider than the one section, of course. So that other section comes on, but kind of a basic field. Headlands, drive around the outside. So I mean, other than turn on, turn off, a little bit of schmutz here at the start, and then that turn off or that last pass, there isn't a lot of overlap. So any guesses on what that would be for overlap? It's more than you think. So let's figure it out. So what this does is every one of these is of course a triangle. All the individual little triangles make up the grid, and all of these belong to individual patches, and the patches are a collection of triangles. So what we can do is draw out individual patches and then record how many pixels of normal color there is, and then overlap other patches on top of it, and when that is bright, then we know that that's an overlap. So all I do is count the difference between the not overlap pixels and the overlap pixels, and from that you get a percentage, and you can multiply the percentage of the total area and determine what the actual area is. So tools, actual area, and then start. So here you can see the individual, the greener ones are the brighter green are the base patches, and then these ones flashing around are all the other patches compared to this. And once in a while you'll see a little bit of bright green, and that's the actual overlap being measured. This is quite math intensive, but it does work actually quite well. So again, if you thought there was hardly any overlap on that field, it was 7.8% was overlapped. So almost 8% of that field is overlapped. So what you thought was 3.4258 acres is actually 3.1591. Cool.